we are going to go ahead and get started. You are more than welcome, everyone, to this Ask the Experts session. It's April, and we have a very special guest joining us today. It is Kit Merker. He is the CEO of Plainsight, and I'm going to let you say a few words, Kit. We're so happy to have you join us.
Hey there, nice to see you, everybody. Kit Merker here. I'm the CEO at Plainsight, as you said. Plainsight is a company that builds vision infrastructure software, make it easy to turn cameras into spreadsheets. We're going to show you that in just a couple minutes here.
Awesome. Thank you so much. And then, as usual, we have our in-house expert, Fredrik Jansson, joining us. You're also welcome.
Thank you. Thank you. It's good to be here. So I'm Fredrik Jansson. I'm a solution architect with Avassa. And yeah, really happy to have you on the show, Kit. Been looking forward to this one. So today we're gonna, maybe we say something about this first.
I would be happy to. So the topic for today is related to Edge AI, and Fredrik is going to dive straight into that in just a minute. I just want to point out that our experts are here today to also answer the questions from you guys who are calling in. So if you have any questions at all throughout this session, feel free to either post them in the public chat or send them directly to me. And either I'll interrupt our experts and get some answers straight away, or we'll have a Q&A at the end of the session. And with that, let's actually get to the good stuff.
Sounds good. Yeah, so today's agenda will be, I'll just briefly show a couple of slides on how we see it around lifecycle managing models for Edge AI. And then I'm gonna hand it over to the man of the hour, Kit here, to talk about the really cool things. And you also have a demo, right, that you're gonna show?
I do. Yeah, we'll see it in action.
Yeah, cool, really cool. And then, as Amy said, at the end, we'll have a Q&A for any questions you may have. So let's get started. A couple of intro slides on how we see it, that MLOps meet like traditional DevOps type style. So on the right here, we see the traditional, you build software and your ops guys push it to the edge in this case. And on the right-hand side is typically where we at Avassa see ourselves, where we take containers from a registry and distribute them to multiple, in certain cases, thousands of locations. But what is really cool, we believe, is when you tie this into the machine learning story, which means MLOps, where you actually can tie your models into your DevOps pipeline, putting models into containers, which is mind-blowing to some. But our opinion is that it's the right way. The container format has many benefits. You know how to build them. You can build put your models into a container the same way you put a computer program into a container. And basically what you end up with is something like this, where you typically have some type of model serving system at the very bottom, and then you have your model sitting on top of that, and all of that is deployed using the container technology. And what is really cool then is, as you develop your model, if you stay on the same version of your model serving system, the only thing that needs to change is that single layer model. And for example, with the Avassa tooling, we can make sure that you only download the model serving server once, which is important in many cases because many of our customers do have limited bandwidth. So actually saving on not downloading stuff twice when you can do it once is important. And yeah, so just a way of trying to exemplify how we see that you can put models into containers and using a system like ours to actually distribute it and deploy it to multiple locations. So that's all I plan to say. So I'm actually gonna hand it over to you now, sir.
Thanks, Fredrik. Yeah, so the model lifecycle that you talked about in this application lifecycle is a really important part of any application, but more so even now with AI and computer vision, it's not just about the software, it's also about the data and how the data flows, what we call the data supply chain, right? How you take data from the world and bring it into your environment. So just to briefly introduce my company, Plainsight, I'm the CEO. We're a computer vision infrastructure company. We automate the infrastructure that supports vision at scale. We like to say we turn cameras into spreadsheets, and I'll show you how that works in a second here. Really the key thing though with vision is that it's not just about the AI, it's also about the software lifecycle and managing these various life cycles as you just discussed together to ultimately build applications that use AI. So when you want to eat all the world's data, how do you do it? One bite at a time. And so really we have to start with the smallest unit of computer vision, which we call a filter. A filter is a containerized computer vision application that combines, as you were describing before, combines both models and code and allows us to process frames and video at the unit level. And so by combining and composing multiple filters together into various pipelines, we can take image data, video data, camera data, process it both in the edge and in the cloud, at the edge or in the cloud, and output that data into the glorified spreadsheets of the enterprise, systems like SAP and Databricks and these other systems that keep track of all the enterprise data that we really care about. So it's not just one pipeline though. It's easy to think about, okay, I have a camera and I just run some inference on it and then I get the data I want. But actually, you need to take a step back because the question is, where do you get the model and the software that you're going to use to actually run the inference? So if you think about those filters, what they really create is a vision workload. Okay, if you imagine there's web workloads, there's data workloads. This is a vision workload. A vision workload is taking image data, processing it using these filters, and orchestrating that to get the outcome we want. So there's really 3 steps in the process. The first is.
Can I just ask a real quick question? I think. Can you give some examples of different filters?
Yeah, for sure. That's a great question. So yeah, in this library of filters, one filter might be an OCR filter, is just a very clear example, right? OCR, optical character recognition. Yep. You don't need to reinvent that every time. You can use OCR in a variety of locations. But before you run OCR, you might want to identify that there's a license plate. Then you would take the license plate and run it through OCR. So now what we've done, we've taken that vision pipeline and we've broken it down into smaller steps. Okay, so there are many other examples of it. Everything from frame deduplication to counting cattle to seeing how long a car is waiting in a drive-through to saying whether or not you put the avocado on the salad. These are all examples of filters. But the thing we found is that even though the use cases are business specific and industry specific, the infrastructure isn't, right? Computer vision is a core technology that can be used across many, many different industries. And so we're really trying to sit at that infrastructure layer and provide this development platform, which works perfectly with Avassa because we don't want to be in the business of deploying containers to the edge. We want to build the best vision apps we can. So in this process to get us to model inference, right? The first step is we got to get from the camera to an annotation pipeline. If you're familiar with AI training and ML training, you'll know about annotations, which is the idea of taking an image and you actually send it off to humans, and the humans define the truth in that image. So you might have them, drawing a bounding box or some sort of shape around an image, and then that's used to train and test a model. Okay, so the first step is we take the data from the camera and we put it into an annotation pipeline. We send it out to humans to define the truth. You may have been part of this, by the way. If you've ever done a CAPTCHA where it asks you to find a motorcycle, that's exactly what you're doing. Okay? Yeah. In the business context, that's done usually as a project and outsourced to people around the world to do this as a way of making money on the side or for their full-time job. So once we have the annotations, that's done in a batch.
So just to because I don't fully understand this, but in your previous example, you said a license plate, for example. So would that be making a bounding box around the actual license plate and tell the system that this is the license plate in this?
That's exactly right. Yeah, it's a slightly tedious job, and luckily there's lots of data sets out there to get it started. Once you kickstart the process, though, what's really exciting is then you can start to use the model that you've built previously to pre-label and pre-annotate. And so that's what's referred to as active learning. But there is always this kind of human step where you have to define the truth that's in that image in order for the ML, the machine learning system, to learn how to find different different aspects of these images. So step one is we get the data from the camera to ready for annotation. Then we send it off to a bunch of humans to annotate it. We collect that data back. Then now we have annotated images. Again, that's done in kind of a batch process. So then the next step is, once I have annotated images and video, then I put that through model training and model testing. So the training step, that is where we're literally running it through a system like, in our case, Google Vertex, where it's providing all of the images into a system that knows how to build a machine learning model. And then we test it against examples that were not in the training set. So you actually have to split your data between training data and testing data. Otherwise, what you end up with is an overfit model. It doesn't make sense to test with the data used to train. You need to test on different data, okay? So once we've done that and we pass a certain quality threshold, now we say, okay, cool. Now I've got a model that is ready for prime time. We can put it into our model inference pipeline. And model inference is just a fancy way of saying that we're processing the real data, we're getting business data out of it. In this setup, in this vision flow, which is our product, you'll notice we have an edge filter, which we actually run a lot of that on CPU. And this is a really important part of this. You can run GPUs at the edge as well. And all of these filters that use these models can be deployed at the edge. But with this cloud setup, what it lets us do is actually regulate the data and where it's being sent and being further processed in the cloud. So part of the strategy of these filters is to allow you to run simple and algorithmically inexpensive things that then trigger more complex things over time. And as you move to more complex things, you have higher hardware requirements. But what's great is this vision workload world. The idea is that we're able to share resources between the different workloads. So we can run on our Kubernetes cluster, we can run on our PyTorch cluster. We're sharing those resources across all the models and all the workloads. And this is allowing us to get this really great scalable factor here. Whereas you're running more and more vision, you're getting better resource utilization.
So in the typical setup, your customers actually share the resources in the middle. Is that correct? Or
they would do it on a per tenant basis, or it could be shared in a shared SaaS. But typically they're running it across their workloads. But even if you have a single workload, which many of these enterprises obviously have many workloads, right? But even if you had a single workload, these three different pipelines can share those resources as well. So whether you're in the annotation business, the training business, or the inference business, that can all sit on the same infrastructure. But the part I'm going to show you today in the demo is I'm going to focus on this first pipeline, because I think it's an important part of the puzzle. You've all seen demos of model inference, but the idea of being able to take a filter and deploy it for model ingestion, for media ingestion, what we refer to as media ingestion, which is getting that first set of data from the camera and preparing it for annotation. And Avassa makes it super easy to do that. I'm going to show you that right now, if that's cool.
Yeah, absolutely.
Give me 1 second here. I practiced clicking all the buttons. Here we go. And for the sake of the demo gods, I am going to show it as a pre-recorded video. But what you see here, this is the Avassa dashboard. You can see that we've got the media in filter. And the media in filter, as I described before, is effectively a piece of software that we can deploy onto a machine in the lab. I'm sitting in our beautiful lab right now in Woodinville, Washington, USA. And we have a bunch of cool toys in the lab. So the project we're going to show right now is we got a camera set up, and it wants to be used for an annotation project. We're going to take that live stream, we're going to chop it up, and we're going to put it into a GCS bucket, and we're going to do that all with Avassa and Plainsight. Okay. So the first step here is, first step is that we're going to have an application defined using some YAML that's very similar to Docker Compose. And I've got this preloaded in this demo here. So the media in filter now has a bunch of configuration set up and very straightforward. And of course, the YAML files can be stored in source control and all that good stuff. Once we have the application defined, then we want to set up the vault. And the vaults, we're going to define secrets. Now, in our case, we're pulling the Docker containers from JFrog, and we have Google Cloud Storage, or GCS, that we're going to use to upload the images. So we need all those secrets. I've got them predefined here. And that's all easy to configure and manage with Avassa. Again, something I don't have to worry about now because I got it all set up. Once we are happy with our secrets, then the next step after that, I'm going to jump forward a little bit. The next step after that is to define a deployment. And then in Avassa, we create a new deployment. We're going to target a specific machine here in our lab, but this, of course, can be used to target any edge device that's connected around the world that you have access to. And again, the secrets are all managed inside of the system, so you don't have to worry about the security of that. Once we create this new deployment, we're going to push that to a machine that we affectionately refer to as the filter beast, which is our biggest, baddest, most GPUs NVIDIA box that we like to run here. And we run lots of containers on it. So the deployment's already running right now in this video. And you can see it just went live. Everything went green. So very quickly, very simply able to take this container, deploy it. Now that container is deployed, we can flip over and see the live feed of the camera. I'm going to show you that. The live feed of the camera at the time of this recording will show up here. And by the way, this video is also available in a blog form on the Avassa website. So here we go. So we got a little train set. I know the lab is a lot of fun. We got a few random objects on the back of the train. We use this to mimic conveyor belts. But now we want to take these different objects and we don't want just a live stream video. We need to have snippets. So those snippets are going to show up here in GCS. This is the Google Cloud dashboard. And those images or those video snippets are uploaded and ready for annotation. Then you can take it easily into an annotation platform. We partner closely with Encord, which is a great annotation tool. And then you get the annotators, and then we can move on to those other pipelines, right? You can use it for the training and testing experience, and you can also use it for inference once the models are trained. So you can see video snippet here, cut down from the live video, ready to go. And you can also do some pre-formatting. But the other cool part is you could add to this, once we have a model trained on scissor detection or pumpkin detection, you could start to pre-annotate those images. So next time around, the humans have less work to do in the annotation. Yeah,
got it.
There you go. That's my demo.
Really cool. So how long are the snippets typically that you take?
It can be as small as a single frame. In fact, that's very common, is to do it as a single frame. That's all configurable. In this example, I think it was set up to do something like 30-second or 1-minute snippets. But but you can imagine if you have a camera running 24/7, right? That's a ton of data coming in. And in a lot of cases, there's not much action. So if we, imagine a security camera and they have an event, once a week. We only care about the thing going on in that event. We want to make sure we dump all the rest of that video. If we never even send it to the cloud, we're saving all that storage, we're saving all that memory, all that bandwidth. And so you can imagine in that scenario, right, we're deploying this media ingestion filter using Avassa to a camera or to an edge device. We're cutting out 99% of the video and just getting the frames we care about. That's a huge savings for people who are worried about this problem. Otherwise, you got to go do it by hand. You send it off to your team to go and watch the video and cut out frames. That's a huge waste of time.
Yeah, no, I can imagine.
So Kit, to that point, I actually received a question that I think you're sort of touching on to the subject right now. Was it a design choice from scratch to have the filter component of the Plainsight product running at the edge, or did you ever consider a cloud native solution?
I would argue that this is both options. So one of the great parts about the filter, because it's built on Docker, it really can run anywhere that can run Linux. So the very same filter can be deployed in the edge or in the cloud, and it can work together. And that's as part of our principle. The design principle is to write once, run anywhere, and to decompose it. And really to think about this as, typically you'd see a monolithic application built using AI and built to do this inference. We think of it, the vision, by breaking it down into these smaller components. We increase reusability, we increase composability, and we increase the ability to orchestrate for resource optimization. So you can do both. And if you have edge GPUs, the reality is what we found is most customers don't really want edge GPUs. They're expensive, they're hard to maintain. So they want to have some lightweight edge. And we've kind of met that need by building lighter weight components that can be deployed to the edge. But if somebody has GPUs at the edge, of course, you can deploy the apps and you can compose them into deployable applications to run at the edge and just stream the data. But to the full life cycle, as I was describing before, if you want to do training and inference and improve your model to high accuracy, you're going to need to get data off the cameras into the cloud. hopefully that answers the question. Yeah.
Yeah, thank you. And to that point, do you see any specific verticals being more cost sensitive when it comes to GPU investments than others?
Everyone's cost sensitive, of course, but yeah, it's a great question. I think there's a really interesting study that was done by Svanberg et al., which is I think it was a Swedish researcher actually. So there you go. But they looked at the ROI, the return on investment. By the way, in computer vision, ROI means region of interest, as I'm always reminded. So anyway, but the return on investment of various computer vision use cases, and what they found was that there's actually only a limited set of cases that pencil out. And at the end of the day, for businesses, what we're replacing, right, is a human. We're replacing a brain and two eyeballs, right? And if you can't offset or improve that labor, you really can't justify the cost of computer vision. So part of our mission at Plainsight is to dramatically reduce that cost, so we can open up new use cases for businesses and make it much more effective for them in doing this. Everyone, especially as the world has uncertainty economically, right? Everybody's concerned about both constraints. One is, can I invest in new technology that's, and if I do, how am I going to justify it? And then also, what am I going to do about my labor costs? And so there is, I think, an argument to be made here that technology can help in that, but you have to do it right. You don't want to run after science fair projects. You want to have a very clear ROI. And we tell customers all the time, look, you don't want to do this. This crazy idea you have, you don't want to do it. Let's try to make it much better. Like, for example, a customer who wants to, one big area of investment we see right now is, you ever DoorDashed your food or used Uber Eats? There's a huge problem with order accuracy in the market right now, because when food goes out the door to a third-party delivery service, if there's an issue with the order, that's lost money, and it's very hard to remake that order. So we've had a lot of customers come to us and say, what I like is look at the food and then turn on a big red light or a green light and say whether the food is right or not. And it sounds great, right? It sounds great in principle. The problem is, to get that level of accuracy and to take that control out of the human's hands is asking too much. It will be very expensive, and it really kind of removes the agency of the human. Instead, what we propose to people in this world is to build a co-pilot, right? Create a screen that has the order, and it just tells you whether the AI noticed the thing that was on the order or not, and it's a helpful reminder to augment the human. And I think this mindset, right? Then what we end up with is we can do a lower cost solution. We can live with lower accuracy. We're being dignified in the human, but we're still making them better at their job. If we can do that correctly, and it drives bottom line because we have fewer orders going out the door incorrectly, even a small improvement is a huge benefit to these businesses. And it does take some thinking, though. You can't just say, oh, I'm just going to wave my hand and let the AI solve the problem. You have to design a solution that takes all the factors into play. And so it's a fantastic question about cost sensitivity. But we try to be smart about costs everywhere we look. Yeah.
Really cool.
Fair enough.
So I have a question that is a little bit off topic, but I can't help myself, so I'm going to ask it. So my understanding is that you have been working with Kubernetes at Google. Is that correct?
I was one of the original team members on Kubernetes at Google back 10, 11 years ago. Yes, that's right.
Really cool. So we at Avassa, we have deliberately chosen not to run on Kubernetes at the edge, and we do get questions around that. Could you share some thoughts on using K*S at the edge?
Well, first of all, I have to be a Kubernetes maximalist. It should be everywhere. No, I'm joking. I think that Kubernetes is actually much more useful in the cloud than it is at the edge, to be honest. And I think, as app packaging, I think the other project you're referring to is K3S, right, which was created by Rancher, which I actually used in a demo I built when I worked at JFrog to build a self-driving car demo back many years ago. We used K3S, and we ran some cool stuff with AI long ago. And it's a great project, and it's awesome. But I think it also does add some overhead to an edge device. And I think the edge is much more sort of singleton kind of devices, right? And in our scenario we showed earlier, you don't really need a cluster. You can have the Docker image, but in the cloud, it's very valuable to have this microservices architecture, orchestration, resource utilization. But if the resources are not elastic or the workloads are not elastic, I think it's probably overkill to use Kubernetes in that scenario. That would be my off the cuff take on that.
Cool. Cool. I appreciate that.
Not a controversial opinion in this room, in this specific room.
Sure.
You're in good company. So I did receive another question. I think it's worth hearing answers from the both of you. So how common is the use of containers for AI models?
It's getting more common all the time. So, the thing to remember is that machine learning models are, I hate to make it simple, but they're sort of complex configuration files is kind of how I think about the output of the AI model. I know there's a lot of complexity that goes into them, and they're engineering marvels, let's be honest, right? It's convolutional networks and all these different model architectures. But end of the day, it's a software artifact, it's a file, and that file is driving configuration. You could replace that with a bunch of if-then statements. It probably won't be as smart, but you could, right? You could do something like that. And this is really, I think, what the model is as an artifact. So the model kind of just sits there. It needs interpretation. It needs some trigger for inference, and to be used in the context of business logic and application logic. And so what I see and what we're really getting traction on is the idea of fusing together the model and the code and treating those life cycles, as Frederick showed earlier, treating those life cycles as part of this end-to-end solution. And what we're seeing is that people who traditionally it was, data scientists produce these models, application developers produce the code, they never speak to each other, they have different tooling, they don't understand each other. But the Docker image and the container becomes an interface of collaboration. And I think this is really the key to the whole story. It's not that we should talk more, it's that we should move our meetings into APIs, right? And if we can agree on those APIs and we never have to talk to each other, everybody's much happier and we can just, have a beer. We don't have to argue or have meetings to coordinate. And that really, I believe, is why containers are such a powerful part of the story. AI apps are just apps, right? It's the mindset. Yep. And so if we can kind of fit that, then we get the benefit of all these tools that have been designed over the last decade, right? From, when Docker was introduced in 2014, right? We can use all those tools that have been developed to now accelerate the scalability, reliability, security, and performance of our AI applications. And that is, I think, the reason why you want to not build a parallel ecosystem. You want to fit to the ecosystem for software infrastructure that already exists. And that's the mindset we've taken.
Yeah, no, I agree with the customers that we have that are using machine learning or looking at it or really looking at putting models in containers. And we also see vendors like you, we see it from Databricks that output from the tooling is a model in a container nowadays. So I think you're right on point that it's going to keep coming.
Cool.
The next phase, by the way, is going to be moving it all into WebAssembly. I think that is, we're not doing anything with WebAssembly yet. Yeah. But I can imagine a world where, the migration from Docker to WebAssembly becomes pretty big, and we're seeing a lot of interest in that kind of attitude. But you got to crawl before you can fly, right? So there we go.
Yeah, right. Yeah. Learn how to code in Rust so you can build your WebAssembly.
That's exactly.
So we are almost on the half hour. I'm going to squeeze in the final question. So a short and sweet answer, maybe from Frederick, referencing the secrets that you showed in your demo kit. Is the Avassa system dependent on cloud connectivity to leverage those functionalities?
Not really. Once you have the secrets and the application out to the edge, we're really not dependent on cloud connectivity at that moment. And at that point in time, we have everything we need on that machine at the edge, including secrets and images and configuration and all of that.
Great. So we are on the half hour, so we're going to have to wrap things up. Thank you so much, Kit, for joining us. It was a pleasure having you. And thank you, everyone, for dialing in. We will return with a new Ask the Expert session later towards the summer. And for now, we say thank you.
Thank you so much.
Thank you. My pleasure.